Welcome to Brain Vision.
So in this question, since we have a changing volume and a changing temperature, however, everything else remains constant, so we can use the relation V1 over T1 equals V2 over T2, since when everything else is constant, volume over temperature will always equal the same thing, and therefore this equation holds true. So our V1 in this case is 1.55 milliliters, and our T1 is 95.3 degrees Celsius. And I'm going to convert this to Kelvin by just adding 273.15, which is the conversion, and then we get 368.45 Kelvin. Now V2 is what we're looking for, and T2 is 0 degrees Celsius, which again we add 273.15 to convert it to Kelvin. And now the reason I'm converting to Kelvin here is since the degrees Celsius will cause T2 to be 0, and dividing by 0 is not possible. So converting to Kelvin is the best way to solve this problem. So if we rearrange this equation to solve for V2, we get V1 over T1 times T2 equals V2. And so if we plug in the values here, we have our V1 is 1.55 milliliters. Our T1 is 368.45 Kelvin. And then our T2 is 273.15 Kelvin. And now the reason I didn't convert milliliters to liters is because in this relation, the individual units don't matter as long as they are the same for both values. So both values of volume need to be the same, and both values of temperature need to be the same units. And so since I left this in milliliters, we'll just get our answer in milliliters. And that answer, when you solve this, is 1.55 milliliters. So that is the final answer.